Okay, these are the answers to the practice test questions only on pages 25 through 27. The simple machines unit will be broken down into probably 3 of these videos. Number 1, what type of engineer is going to focus on vibration, analysis, lubrication, gears, and bearings? That's going to be a mechanical engineer. Which lever pictured is first class? That is going to be lever A. Number 3, study the gear train. The purpose of the center gear is what? Center gear is the idler gear. All that is going to do is A, allow the drive and driven gear to rotate in the same direction. Number 4, a third class lever. The distance from the effort to the fulcrum is going to be B, less than the distance from the load resistance to the fulcrum. Number 5, when used to pry open a can of paint, a screwdriver functions as a lever. Number 6, given the pulley configuration shown in figure 4, how many pounds of effort force would be used to the user have to exert on the rope to lift a 60-pound load? So what you have to do is you have to first and foremost look at the mechanical advantage of the system. So in a pulley system, you're counting the strands. That's going to be 3. You don't count this one. That's the one that's actually going to be doing the pull, so that one doesn't work. So my mechanical advantage for this pulley is 3. Then what you have to do, you have to set your IMA. So in this case, we'll just go ahead and use the effort distance and the resistance distance. We know the mechanical advantage is 3, so that's going to be where the IMA is. DE is going to be 60, and we don't know this, so that's what we were solving for. So to get the DR by itself, multiply here. So DR3 equals 60, divide by 3, and your answer is going to be 20 pounds. So that's C. 7, a student raising their ramp in figure 5, raise an object 4 feet above the ground. The mechanical advantage of the ramp is what? You need to make sure that you're using this equation. IMA is equal to length over height. The length that the object is traveling is 12.65, and the height is going to be 4. That's going to give you a value of 3.163. B. Number 8. Figure 7 represents a belt-driven system. Pulley B, which has a diameter of 16 inches, is being driven by pulley A, which has a diameter of 4 inches. If pulley A is spinning at 60 RPM, then pulley B is spinning at what? So you have to look at your gear ratio. That equation, your rotation out, or your rotation in, over your rotation out is what we're going to be given. If this has a diameter of 16 and this has a diameter of 4, my gear ratio is going to be 16 over 4, and that's going to divide out to 4. So this GR equals 4. The speed out, we don't know. But the speed in, we do know. That's 60 RPM. Now what you do, you've got to get rid of this. You've got to get the speed out by itself, so you just multiply it here. So 4 times the speed out is equal to 60. Get rid of the 4. Divide by both sides. So my speed out is 15 RPM. So that is option D. Number 9. Simple machine requires effort force, that is mechanical advantage. 10, which when calculating gear ratio, which of the following has an indirect relationship to the others? So it doesn't relate. Torque relates, diameter of the gear relates, number of teeth relate. However, angular velocity is what you're looking for. That has an indirect relationship. The rest of them are directly impacted. And number 11, in the second class lever, that's going to be E greater than. 12. A wheelbarrow is a second class lever. Scissors are first class lever. Work is calculated by multiplying force times distance. That will come into play here in a few questions. 15, according to the following thread note, what does 3/8 mean? 3/8 is going to be your diameter. So an example for the whole thread would probably be 3/8 UNC, and let's just call it 24. So the 3/8 is the diameter. Okay, so this is going to give you your diameter. This is going to identify the type of thread, and this is going to identify how many threads per inch there are. 16, the force of 50 pounds is applied to a 1-foot wheel. The wheel is turning at a 0.25 diameter axle. How much mechanical advantage does the wheel provide? On this one, you need to set up an ideal mechanical advantage equation. So we'll do this one over here. So my IMA is going to be equal to dE over dr. In this case, since it is a wheel and axle, we need to make our effort and our resistance something that we are going to be able to use. So in this case, the dE is actually going to be pi times your diameter. So in this case, the effort distance is going to end up being not 1 foot, but 12 inches. The reason it's 12 inches instead of 1 foot is because this part right here that I've actually kind of got scratched out is in inches as well. It's 0.25 inches. Now, my dr is pi times the radius of my resistance, which is 0.25. So my IMA, if you're doing the numbers in your calculator, you should be coming around 37.699 divided by 0.785. Your IMA is equal to 48.02. So maybe a rounding issue, but letter B is what we're looking for 16. 17, friction is included in a simple machine. The amount of effort required to move a load will be less than or equal to what is calculated using the formulas for simple machines. 18, another name for an input force, that's your effort. 19, the input driver gear is 15 teeth and the output driven gear is 60 teeth. What is the gear ratio? So gear ratio should be on your formula sheet, is teeth out over teeth in. So in this case, my 60 is the gear that is being driven. So it's 60 over 15. 60 divided by 15 is going to be a 4. And that is going to give you the ratio of 4 to 1. Notice here, option C could easily be coming into play there. You need to make sure that you identify which one is the driver and which one is being driven. 20, what can a gear train do? A gear train can do all of these. It can change the output direction, it can change force and speed. 21, a turning or twisting force is torque. 22, given a second class lever with a distance of 5 feet from the fulcrum, the effort and a distance 33 inches from the resistance, what is the maximum amount of weight that can be lifted by the 25 pounds of effort? This one you're going to have to use the moment equations. So moment equals force times distance. In this one, it can be moment effort is equal to effort force multiplied by effort distance. And it can also be resistance moment is equal to resistance force times resistance distance. So now you need to go through and plug in some values. So on your effort distance, the moment is equal to 25 from right here, multiplied by 60, which is 60 inches, excuse me, that comes from the 5. Make sure that you put all of the values in the same units. So 5 feet is the same as 60 inches. Everything else is being talked about in inches. So down in here, 33 inches. So if you put the 5 in instead of 60 here, that's going to give you an incorrect answer. That's going to come up to 1,500. Okay, so you're halfway there. The next one, resistance plug in the values. We've got a moment equal to some force multiplied by the 33. 33 comes from here. So now what you have to do, you know that each moment is going to equal out. So this has to become F33 is going to be equal to 1,500 get rid of the 33. So 1,500 divided by 33 is going to give you an answer of 45.45. So C is our answer for 22. 23, suppose a wheel with a 15-inch diameter is used to turn a water valve stem with a radius of 0.95 inches. What's the mechanical advantage? Go back to this equation. IMA is equal to DE over DR. And what we're going to do is we're going to use pi times our diameter of our effort, which in this case is 15. 5 times 15 over pi times 0.95 times 2. So in this one, this is radius. So you need to make sure that you make this number 0.95 multiplied by 2. So the radius, or the diameter, was given up here. This one was giving you radius. So you need to make sure this point right here, you absolutely positively put 0.95 multiplied by 2. So you plug that into your calculator, it should give you something like this, 47.123 over 5.969. That's going to give you an answer of 7.89. So option B for number 23.